This classwork, the first thing we're asked to do is to perform a check, see whether the given ordered pair is a solution to the system of equations. The way that I perform this check is basically I take the x coordinate, I plug it in where I see an x, I take the y coordinate, I plug it in where I see a y. If the first equation gives me a true statement, I move on and do the same thing to the second equation. As long as they're both true, then I say yes, this is a solution to the system of equations. If they're not both true, if either of the two is false, then I say no, this is not a solution to the system of equations. So, 2 plus a negative 1 equals 1. 2 plus a negative 1 becomes 2 minus 1, which becomes 1 equals 1 and gives me a true statement. When I go to plug into the second line, 3 times 2 minus negative 1 equals 5. On the left-hand side, 3 times 2 gives me 6. Negative times a negative 1 gives me plus 1. Plus 1. If I take 6 plus 1, I get 7. When I check the 7 equal 5, no it does not. So this is not a solution to this system of equations. Yes, the point 2 negative 1 was on this first line. No, it was not on the second line, so no, it is not a solution. When we're asked to solve the system by graphing in 2a here, this line is already in y equals mx plus b form, so I don't really need to change it. This one I just need to change slightly in order to put into y equals mx plus b form. So it starts out as x plus y equals 0. If I want the y by itself on the left-hand side, the x is what needs to move. It's a positive x now. If I do minus x here, I'm left with y equals negative x. This is in y equals mx plus b form, where there's an understood 1 here, so it's a negative 1 as a slope, and there's an understood 0 here, so it has a y-intercept of 0. This was already in y equals mx plus b form, so both of these are ready to graph. When I go to graph this equation, what I really need to see is that the slope, or what's in front of the x, is an understood 1 or is a fraction 1 over 1. The intercept is 0, comma b, in this case negative 2. For this equation, the slope is a negative 1 over 1, and the intercept is 0, comma 0. So if I put these in, this starts at 0, negative 2, 0, negative 2. From there, I go up 1, rise 1, over 1, run 1. Up 1, over 1, up 1, over 1. This would be the general form of this line. If I now go to do this line, I start at 0, 0. This tells me I go down 1, right 1. Down 1, right 1. Down 1, right 1. So the general form of this line looks like this. I can see they hit an exact point. If I try and describe what this point is x value, right 1, y value, down 1. X value, right 1, is first coordinate 1. Y value, down 1, is second coordinate negative 1. This is the solution to this system of equations. I can always do my check. If I put in 1 and negative 1, 1 minus 1 does equal 0. If I put in over here, negative 1 does equal 1 minus 2. So I could plug it back in to show that yes, this is the solution. I do recommend that if you're trying to draw these in by hand. It's really easy to get confused over where they intersect. That said, hopefully if you're doing them in the web-assigned system, it's not so bad. It'll see where exactly things intersect with the grid lines that are already provided for you. When I go to do part B, both of these equations need to be changed in order to be put into y equals mx plus b form. So the first equation that I'm going to start with, x plus y equals negative 2. This x is in the wrong spot, so I'm going to minus x here, minus x here. That gives me y equals negative x minus 2. This is now in y equals mx plus b form specifically. The slope is negative 1 over 1. The intercept is 0, negative 2. I'm going to now look at the second equation. So it starts out negative 2x plus 2y equals negative 4. I'm going to add 2x to each side. These go away and I'm just left with 2y on the left. On the right, I'm going to write it with the x term first, 2x, then the number term minus 4. This is in terms of 2y, not 1y, so I need to divide by 2 to get in y equals mx plus b form. What I do to the left-hand side, I have to do to each term on the right. So divide by 2, divide by 2. That gives me the equation y equals x minus 2. Here there's an understood slope of 1 over 1 and an intercept of 0, negative 2. So, turns out these have the same intercept. That's going to be my solution. I still want to graph it to show that that's how it works out. So if I start this line at 0, negative 2, it starts down here. Then it says we go down 1, right 1, down 1, right 1, down 1, right 1. This is the general look of that line. This line also has an intercept at 0, negative 2, except it goes up 1 when it goes right 1. Up 1, right 1, up 1, right 1. So this would be the general form of that line. Again, this one's somewhat easier than they really should be because the intercept is what's the same. So I can see right there, they both have this same point on there. So the solution point is really 0, negative 2. I begin part C by solving the second equation for y. So the top one already has y equals mx plus b form. This one does not. So it starts as x plus 4y equals 4. I see the x is in the wrong place. I move it by subtracting x. These go away and leave me with 4y. On the right hand side, I'm going to write it as negative x plus 4. If I now try and get 1y, I need to divide by 4 since it's being multiplied by 4. That means each term on the right also has to be divided by 4. On the left, these 4's go away and just leave me with y. On the right, this is an understood negative 1 over 4, so I can break that out as a fraction. Negative 1/4 x, and then 4 divided by 4 gives me 1. I could now go ahead and find the slope and intercept in order to graph these lines, but if I look back and see what the original line was, these are literally exactly the same. If you recognize you have two of the exact same line, you can stop there and say that this is a dependent situation. I'm writing it in capital letters because that's how it's asked to be inputted into the system. Other ways you may have seen this in other classes are infinitely many solutions, same line, all of that is true, but they want you to write dependent in capital letters when this occurs, when you get the same exact y equals line. For both of these lines, I would have the slope m equals negative 1/4, and I would have the intercept of 0, 1. So really, if I was graphing this, here's 0, 1. From there, I'm going down 1, right 1, 2, 3, 4. Down 1, right 1, 2, 3, 4. So the graph would look something like this. Really, when I go to graph the second line, it would be the same exact thing. I would just be darkening in the same exact line. For that reason, if I choose, for instance, something like x equals 4, at that point y equals 0, so a solution could be 4, 0. But another solution could be 0, 1. Another solution could be 8, negative 1. So since there's all these different solutions that represent any possible point on the line, That's why we call it a dependent system. Dependent in the sense that I can tell you what y is depending upon what you tell me x is. Whereas for our consistent systems, they meet at one single point. They only have a single x and y that would work to solve the system. Moving on to part D here. Again, I have one of the equations already solved for y. I just have to solve the other one for y. So I start with x plus y equals -1. I'm going to subtract the x here, subtract the x here. On this side it goes away and just leaves me with y. On the right hand side I'm left with -x minus 1. Again, I could pull out slope and intercept here. Or I could look back to the other equation and see, well, hold on, these have the same slope but different intercepts. We know when we have two lines to graph that have the same slope but different intercepts, it's an inconsistent system where basically you're going to get two lines that are parallel and will never touch. So because I see that this and this are the same, really an understood -1 in front of each of the x's, I then look to the intercept because this is a +1 and this is a -1. They're not the same slope, different intercepts, inconsistent, no solution. As opposed to here, when they have the same slopes and the same intercept, that's when they're exactly the same line and create a dependent solution. So, for this set, what I'm going to do is I'm going to pull out what the slope is for the first line, m equals -1/1, and I'm going to pull out the intercept, which is 0, 1. For the second line, I also have m equals -1/1, except this time I have the intercept 0, -1. Plotting the first line, I go up to 0, 1, put a point. Then I'm going to go down 1, right 1, down 1, right 1, down 1, right 1. This should be the, sorry, that wasn't a great line that I drew, but let's pretend I did better. This would be the general form of what that line would look like. If instead I wanted to plot this line, it would start at 0, -1. From there, it would go down 1, right 1, down 1, right 1. It would create this line. If they were properly drawn, you'd see that they just go on forever and never touch each other. Again, in this situation, we're going to call it inconsistent. Put it in capital letters. That's how the system wants you to put it in when you have this situation. But basically, in each of these situations, I have the same slope from my two lines. Here I had the same intercept, so it was the same line graphically, which made it dependent. Here I had different intercepts, so they were parallel lines graphically, which made it inconsistent.